Hello everybody and welcome back. Today we are going to continue with proportions, and in this case we're going to be applying our proportions that we've been working on to unit rates, scale drawings, and scale factors. So we'll talk about what those are here pretty soon. Alright, some review definitions here. So remember, a ratio is just a comparison between two numbers. So example, we have a fraction here, 3/4. So this could also be written as 3 to 4. That is also another way to write that ratio. All right. So a rate is just a ratio with different units. So in this case, we have $3 to buy 4 pencils. So that is a rate there. And then to take it a step further, a unit rate is a rate with different units, but with a denominator of 1. So we can see here that this guy here, $3 for 4 pencils, becomes the unit rate of 75 cents for 1 pencil. So other unit rates we are used to seeing is miles per hour, because if you're going 60 miles in 1 hour, that is a unit rate because we have a denominator of 1 there. So an example of a unit rate, we can take any rate we have. So Sue can type 60 words in 2 minutes. That is just a rate of her typing. What we can do is whittle that down to a unit rate. So how many words can she type in 1 minute? So all you got to do is set up your ratio here, or sorry, your proportion, and then solve it out. Alrighty. So moving on now. So that was a review a little bit. And I guess unit rate is a new one for us, but not too difficult there. Alright, so scale drawing / model is a drawing / model of a real world object that has been enlarged or reduced by some scale factor. So, some examples here, dollhouse furniture. So if you look at a really nice dollhouse that someone makes, everything in there looks realistic. It's just shrunken down. So it's been shrunken down by some scale factor. So it still looks like it would in real life, just a smaller version. Architect models, people build little models of buildings that are going to be built, or even cities that are getting renovated. They'll build little scale models so that they will look exactly like they will look, just a shrunken down version. And then same thing with Hot Wheels or Matchbox cars. They look like they're bigger counterparts, but they've been shrunken down by some scale factor to be smaller, a smaller model. Alright, so scale factor is the amount that the real-life object is being enlarged or reduced by. So an example here, we have a Hot Wheels car. So its scale factor is about 1 to 64. So that means to make one real-world sized car, it would need to be multiplied by its size. So there's the real car. It would need to be multiplied by about 64 toy cars in order to make up the size of a real car. So that's one real car be shrunken down, so it would take 64 toy cars to make it the size of that, or a multiple of 64 of those cars. All right, so a scale drawing or model example here. So a scale drawing has a scale of 3 inches to 10 feet. If the building in the drawing is 24 inches tall, how tall is the building in real life? So this is going to be a lot like our unit conversions, except we don't need the things to be equal to each other. Like a foot was 12 inches. How many inches is 3 feet? So this is kind of like that, but we're saying they're not exactly equal, but we're setting them equal in order to make our scale factor here. So in this case, it tells us that 3 inches of our model is equal to 10 feet in real life. So there's the first ratio they set up there. And we want that ratio to be equal to 24 inches. How many feet will that be in real life? Well, they just set up their proportion, and then they've done their butterfly method, or cross multiply. So there's the 3x, cross multiply here, and there's that 240. And divide it out, and they get x equals 80 feet. So if a model of this building is 24 inches tall, then the building in real life will be 80 feet tall when they build it. So another way we can kind of think of this is like a map. So if we drove from, let's say, the school to, I don't know, let's say Warrenton for some reason. Well, that's what, about maybe 30 miles or so, give or take. But on a map, we can't obviously have a 30-mile road. So what they do is they use a scale so that on the paper, maybe about 7 inches or so would be equal to those 30 miles. So maps are just another example of scale factors here. All right, so here we go. So I'm going to show you how to work through some of these. So Samantha played online video games for 24 minutes. She was charged $33. How much did 1 minute cost? So we can take this. So it was $33 for 24 minutes. We want that to be equal to same units on top, right? So here's dollars, here's minutes. So we don't know how much. That's what we want to know. How much money did 1 minute cost? And when we do these like this, we can see that x, or 24x, excuse me, is equal to 33. So another way you can find these, sometimes if you're lucky, is just divide the money by the minutes here to get your unit rate, because that's exactly what we're doing here. We're taking extra steps to do the same thing, but it never hurts. So x equals, let me get my calculator real quick. $33 divided by 24 is 1.375, but we're rounding to the nearest penny because pennies is the smallest amount of money we have, so that'll round up to $1.38 per minute. So with these ones, instead of just giving a unit as in $1.38, we're going to give our units as rates here. So x is equal to, each minute is going to cost $1.38. So we're breaking it down into a unit rate here. Alrighty. So next up, David can drive 294 miles on 14 gallons of gas. So see how I just took that ratio right there and represented it on my paper here. how many miles can he drive on 1 gallon of gas? So we want to know how many miles can he drive with 1 gallon. So we've set up our ratio. We're going to use our butterfly method. 14x is equal to, well, this is pretty easy here because 294 times 1 is equal to 294. We are going to divide by 14 here, and x will be 294 divided by 14. So that he's going to be able to drive 21 miles per gallon of gas. So there's once again our units being given as a rate, a unit rate in this case. All right. So here's an example of our scale factoring here. So if a map uses a scale of 1 inch to 15 miles, so we're just going to write that ratio down like we see it. 1 inch to, here, let me write that so it doesn't look like 11 something. 1 inch is the same as 15 miles in our scale. How many inches, x up top here, would be represented by 255 miles? So we can see, just like our proportions before, we're having the same units on the top and the same units on the bottom. This is going to work just like we've been seeing with other problems. Do our cross multiply. 15 times x is going to equal 255. Divide by 15. Divide by 15. We're going to get x equals 255 divided by 15 will be 17 inches on our map to, well, we don't need to write it out as a rate anymore for this one because that's going to just make it look funny. So that means that 17 inches on a map will represent 255 miles in real life. All right, so on your notes page on Canvas, the problems are going to end here, but once again, we've got some of the notes problems on the same page as our independent practice here. So the last 2 problems you are going to see on your assignment page, but do those with your notes and not your assignment. All right, so same thing, we're going to keep on going here. So since they're mixing up decimals and fractions, I'm going to just say let's go ahead and turn this into a decimal. If it was in fractions the whole time, then we would want to stay in fractions, but in this case they've already have a decimal, so let's just work with decimals. Why not? All right, so if 6 kilometers is represented by 4.1 inches on a map, we want that rate to be equal to how many kilometers will be represented by 7.25 inches. We've got our proportion set up, so cross multiply 4.1 x will be equal to 7.25 times 6 is going to be 43.5. Final step here, divide by 4.1, divide by 4.1, and x will be, how many kilometers is this? Divide by 4.1. Tells us to round to the nearest hundredths here. So we get 10.609, but rounding to the 0, because that's in the hundredths place up, we look to the right and have a 9. So this will become 10.61 kilometers will be represented by 7.25 inches on a map. Excuse me. We've got our final problem here. So, a box of Captain Crunch costs $4.32, and the box is 18 ounces. So we want that to be equal to, so we want to know how much money are we paying for 1 ounce of the cereal. What is the unit rate of this box here? So once again, easy to set up our ratio. Or our ratios are set up. It's easy to solve our proportion from here. 18 times x is equal to, well, $4.32 times 1 is just $4.32. Divide both sides by 18, and we get x equals 4.32 divided by 18 will give us 0.24. So each ounce of cereal in this box is going to cost almost a quarter, 24 cents for an ounce of cereal. So 24 cents per ounce, a unit rate for our answer. All right, so that's it for today. So use these steps, use these setups to solve the problems in your independent practice here. Be sure that you're using some area on your paper to show your steps. Always show your steps here, or you will get some points taken away. So go ahead and complete this independent practice on a separate sheet of paper. As usual, take a photo when you're done and turn it into the assignment turn-in spot. If you have any questions, just go ahead and send me an email and I will try to get back to you as soon as I can. Everybody have a great day, and we'll talk to you soon for the next one.